Hello again. So these are notes on how to actually set up these torque questions. Very rarely is the question simply going to be, how much torque do I get from this push? Okay. Usually you're going to have to find out what happens, or find a net torque, right? If we review for a second, when I set up forces, first thing I did, right? Free body diagram, right? And then I set up my F net. And then obviously, like I solve, okay? In some ways, torque ends up being a little bit easier. Oftentimes you can draw a diagram, but it's not quite as helpful as it is in the forces, okay? So we'll put draw. Okay, 2, instead of setting up an F net, I need to set up a torque net, okay? And then 3, solve. The nice thing is, your torques are either going to be positive or negative, okay? So forces, we can have an X, Y, and even a Z axis. For angular stuff, we're mostly either worried about clockwise or counterclockwise. Okay, I may have gotten that backwards. But we're either worried about a rotation in one direction or rotation in a different direction. We don't need to worry about rotations in multiple different directions, okay? So that does make it a little bit easier in that we don't need to worry about, like we did on the forces, where we had an F net in the X direction and an F net in the Y direction. For torque, we just need to worry about a positive torque or a negative torque, okay? So let's go ahead and look at this specific question. We have a 500 kg steel beam extends horizontally from the point where it is bolted to the frame of a building. A 70 kg man stands on the far end of the beam. What is the magnitude of the torque at the point where the beam attaches to the building? So let's go ahead and draw a picture just to help us visualize. So here's my building, here's my beam, here is my person, okay? Now, how many forces are acting on this beam? So this is kind of a trick question. There are actually 2. So I have the person, obviously, okay? I got an mg there. And what is the other thing that has mass? Yes, the beam, okay? Now, the beam's mass, we are going to put where? Where do you think we're going to put it? You think we're going to put it here, 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 where? We're going to put it at the center of mass, okay? So in this case, just in the middle. And this will also be mg, okay? So then I also want to go ahead and just make sure I put the distances here, or at least one. So this full thing is 4 meters. Okay? So just like I would do for F, where I would say something like F net equals F1 plus F2 plus dot dot dot. I'm going to do the same thing here. Okay? So my torque net is equal to the torque from the person plus the torque from the bar. Okay? Now, are these 2 torques exerting the same direction? Right? Are they causing it to rotate the same way or opposite ways? This is a question I need to ask myself, just like when I have forces, if they're in opposite directions, I need to say, are they helping each other or hurting each other, right? Because I need to subtract one. In this case, I need to ask myself, are these causing it to rotate the same way or opposite ways? Well, in this case, they're both causing it to rotate this way. Okay, so it would be the same direction, so I can just go ahead and add these 2. Okay, so my torque net is equal to the torque of the person, and our formula for torque is RF. Now in this case, we'll notice that the R is here, and the F is straight down. So the angle between these is 90 degrees. Okay, so it's just going to be RF. I could put the sine theta, but that will just cancel out because it's 1. Plus RF sine theta again. Both of these thetas cancel out. So I have R. So for the person, my R is 4. So I'm going from here, which is my rotation point, all the way to here. So that's 4 times the mass of the person, which is 70 times 10 for G, plus the R for the beam is only half that, right? Because it's exerting from the center of mass. So that will be 2 times 500 times 10 for g, so mg. Okay, and then I can just add all this up. Okay, so this should give you this, and this direction is clockwise. So it would be important to note the direction. Oftentimes the question isn't necessarily going to expect you to give a direction, but it would be a good idea to make sure you know which direction it is. Okay? An object's moment of inertia is 2 kg meters per second squared. Its angular velocity is increasing at a rate of 4 radians per second squared. What is the torque on the object? Or it's really asking for what is the net torque. Okay? Now, if I think back and think about what this would be if it was a linear question, it'd be something like an object has mass of 2 kg and acceleration equals 4 meters per second squared. What is F net? Right? And I would say, oh, that's a pretty easy question, right? What's the formula I need to use? Yeah, just F net equals ma. Well, remember, this is going to have an angular version. So I need to make the angular version of this. Okay? So instead of F net, I need to use what instead? Torque net. Okay? So torque net, instead of m, I need to use what? Yeah, I need to use I, right? My angular mass, or my moment of inertia, is I. And then instead of linear acceleration, I need to use angular acceleration, which is alpha. Okay? So I just have my torque net equals I alpha. So when we're encountering questions like this, it will often be something like this, where I have my torque net equals the sum, my vector sum of my torques. And then this.
Thank you, everyone. We're all clear. Thank you. Have an awesome day.
Is equal to my I alpha. Okay? So this would be sort of the general way that you'd set it up. So you'd probably replace this step right here with an I alpha. Okay? If it asked me for something about rotation, as opposed to just what's the net torque. Okay? So let's go ahead and solve this. This will be pretty simple. So my moment of inertia is 2. My angular acceleration is 4. So the net is 8 Newton meters. Okay? So your basic setup is very similar. Draw your picture to help visualize. It's a little bit different from a free body diagram, but a little bit similar. Okay? Then we're setting up our not our F net, but our torque net. Okay? And remember, this means our sum of all our individual torques is equal to our I times alpha. Okay? The nice thing is I don't have to worry about an X, Y, and Z torque. I only need to worry about, is it going to be a positive torque, right? Is it rotating in this way, or maybe I have a pull up, okay? And they'll be maybe canceling each other out. Okay? So I have my net torque equals I alpha. There are some practice questions below to practice these concepts. Remember, if you ever have a question, send me an email. Make sure you put the question in the email so I can respond right away. So that is torque.